Today we are going to discuss about on important topics in our daily usage of life. Is one of the factor is in electronics and components. So now we will incorporate about what is the design thinking principle involved in that particular electronic components device in our daily life usage. Basically, we know that empathy we are carrying stages of 5 stages, starting from empathy and define, ideate, and prototype and test. Now you can share about these 5 stages is how to incorporate in that electronic components device using that heat transfer phenomenon.
So heat conduction is the transfer of thermal energy of a material without movement of the material. So in real world application, in aerospace, the electronic components get overheated due to the limited space and poor thermal dissipation. So to empathize this, first we have to know the problem, how this heat is produced in the materials of the aircraft. So first we have to empathize the engineers and how it affects their performance of the aircraft. To ideate, we have to form a solution by creating a material which stands the thermal property, so it won't get overheated very fast.
So what is that empathy in this design thinking stage?
Empathy is
What is the real life of problem in this you are tackling this problem?
the components is getting overheated due to the limited space. I mean, there won't be enough space for all the electronic components.
How do we rectify this problem as a defined stage?
By creating and changing the material of the electronic components to a heat resistant material.
What is any type of ideate involved in this problem?
You can use carbon composites for this because it has a high thermal conductivity and it also has a less weight, so that it won't affect the flight performance. And then next we can use heat pipes. Heat pipes which is used to transfer heat from hot body to cold body. Also we can use aerosol insulation. It increases the thermal resistance, which is helps to decrease the heat for the electronic components. Next is thermal straps. Thermal straps are flexible conductors which we can use in compact spaces, which is also helps to reduce the heat conduction in electronic components.
So any type of prototype materials you have incorporated in this?
Yes, as my friend said, we could add carbon composites and a lot of aerogel in this components in this PCB cycle, and which will greatly reduce the heat that is dissipated. Since now they are mostly using silica-based components in the electric circuit, which is a good conductor, but it also dissipates a lot of heat as a energy loss, which in turn makes the components melt in some cases and catch fire so easily or short circuit the entire system. So we could create this PCB with aerogel components and carbon composites, and later we could put this in a similar simulations where this test could we could run these tests and we could take the results out. With this test we could rectify that the changes made, we could potentially make around 73% less heat generated by incorporating aerogel and other carbon composite substance instead of the silica, which is currently we are using in the PCB circuits right now.
So you have mentioned any type of example material for this in this case study, in this design thinking problem for this topic.
Yes, sir. Like aerogel component is really rarely used. There are some cases in which silver component is used in making the PCB, which is really a good conductor and which is a lot better than the standard PCB right now. but the only issue is silver is really expensive, so they are not there's not an abundant resource for it.
Okay, and now you have to search relevant topics in design thinking based heat transfer applications in the future. Thank you.
Right.